Aquaponics is the combination of aquaculture, which is the raising of fish, and hydroponics, which is the growing of plants without soil. The waste given off by the fish provides nutrients for the plants, and the plants in turn filter the water in the system, creating an environment for sustainable growth that can provide fresh food even in the heart of urban environments. In our aquaponics system, we utilized a single 57-gallon tank which provided a home for numerous goldfish, which were chosen for their cost-effectiveness and resilience. Additionally, we chose to use spinach, common sage, basil, and green beans. These plants have the potential to provide essential nutrients to the target human populations, including iron and vitamins A, B, C, and K. Also, the green beans were chosen because as legumes, they would have nitrifying bacteria in their roots, which would facilitate the cycling of nitrogen throughout our system, which is important in the creation of proteins and nucleic acids. Another important cycle is the water cycle. Due to the presence of the styrofoam lid, most of the water was lost through transpiration from the plants into the atmosphere rather than evaporation. Another cycle that affects the function of the tank is the carbon cycle, which played an essential role in the processes of cellular respiration, which creates energy, and photosynthesis, which creates glucose. This glucose can then be polymerized into various polysaccharide carbohydrates like cellulose, starch, and glycogen. In our tank, we saw relatively successful plant growth. Though our basil and spinach plants did not survive because they did not have sufficient root growth, our sage and bean plants both prospered. When examining the change in root length over time, we can see a steady increase, though it is not quite exponential. Additionally, the plant growth curves can be used to infer that the rates of photosynthesis increased, because plants are made largely of cellulose, a polysaccharide of glucose. When examining many of the abiotic factors in our tank, one can see that many factors such as room and water temperature, pH, and nitrite levels remain fairly constant. However, we saw large changes in the general hardness and carbonate hardness, but both rose and fell at the same time, indicating a possible connection. However, we did create a somewhat inefficient system. While the crops received nourishment through the water, carbon, and nitrogen cycles, the fish would have to be fed from an outside source because goldfish are carnivorous rather than herbivorous or omnivorous. As a result, the food web and energy pyramids for our tank are disconnected. Additionally, because the goldfish do not eat plants, they are on a much higher trophic level, which means that more energy is lost through the system. In order to improve the efficiency, we would replace the goldfish with an herbivorous fish like catfish. Another change we would make is using multiple smaller tanks, which would enable us to better isolate nutrient deficiencies and disease. Additionally, in a smaller tank, the same airstone would create a current that impacted a larger portion of the tank, making the fish swim more, thus doing more cellular respiration and releasing more energy as heat. This, combined with the introduction of insulation to the bottom and back of the tank, would better conserve heat, reducing the energy that must be put into the system. Aquaponics systems are the future of farming, creating the potential to reduce food deserts and improve nutrition.